Okay, for this question, 3A here, they have another diagram, right? Figure 1 showing you destructive plate boundaries, direction of the plate movement. So you can actually see that this area here is the North Pacific Ocean, which means that this is the Cocos Plate pushing against the Caribbean Plate. And evidence of a string of major volcanoes starting from Rincon de la Villa in the northwestern part of Costa Rica, stretching down towards the southeastern direction to the volcano Irazu. Okay, so these are your stimulus. By looking at this, at the back of the head, you should already know that this is a convergent plate boundary. Oceanic, coast coast, and Caribbean. At this point, oceanic, so leading to the formation of volcanoes and foam mountains. So the question itself is this. The next one they show you is your two plates, okay, two plates converging and then the arenal volcano being formed. So when they ask you to use both diagrams, figure 1 and figure 2, show how location and volcanic activity are a result of plate tectonics, what are you supposed to highlight for the 5 marks? Number 1, you need to tell me what kind of margin is shown to you. Okay, is it oceanic? Is it oceanic continental? What is your evidence? Okay, what does it tell you in figure 1? What does figure 2 tell you? Does it corroborate with what you mentioned earlier? If it does, then tell us. Okay, tell us what you see in figure 1 that tells you this, what you see in figure 2 that tells you this. Okay, and then what happens? Okay, how the arenal volcano was formed. Okay, because of this particular type of plate margin that was located here, how this thing was formed. So remember, this is a data response question, so you do need to do the quotation. If you don't have any data quotation, you just give us a description of how volcanoes can be formed at oceanic plate boundary. You will not score 5 marks. The maximum you will get is 3 marks. Okay, you will pass, but you will not get a good score if you don't refer back to the figure itself, because this is data response. Part 2 gives you yet another stimulus. Okay, another stimulus, if you look at it very carefully, this is an area where you have a zoom in area, topographical map of the arenal volcano, okay, showing you where the lava flow occurred in the previous eruption. Okay, sectors, risk areas, R1, R2 and R3, footpaths, certain amenities and facilities that are built, certain attractions, where do you find all these things. So they want you to suggest ways in which tourists and local people have benefited, okay, firstly from the developments around this volcano here. So what is the main benefit of this area? Is it tourism, right? Can you see evidence of tourism? Is it geothermal energy? Do you see evidence of that happening? Or is it precious metals, mineral, sorry, right? Or is it fertile soil? So by looking at the key and the legend itself, you should be able to identify what are the key benefits of this. Okay, how does it benefit the tourists? What are the tourist attractions in the area itself, right? So do you only talk about visiting the volcano for scenic beauty, or are there other services that you can see within the map here? If you look at the north, right in the middle, okay, the northern part of the map, right in the middle, you actually do see a resort and spa. Okay, resort and spa, you do see the lodges, you see the Tabacon hot spring. So these are your additional amenities that are a result of the volcano and the volcanic activity in the area. So besides talking about scenic beauty, you also need to talk about these other potential tourist benefits. So part 3, same thing, look at figure 3 again. They want you to explain why the volcanoes are dangerous and why different risk areas are designated around the volcano. So when you go back to the previous, the figure 3 here, you must be able to identify clearly there are 3 zones. Zone R1, which is the circumference that is very near the volcano, R2, slightly further away, and R3, a significant distance away. Okay, so R1 means you are within a kilometer of the crater itself, where you're in the direct impact of the crater. And any sort of eruption, you are in the immediate destruction zone. Okay, R2, which is about, I would say, 4 kilometers, 3 to 4 kilometers away, and then R3 is a further 6 to 7 kilometers away from the crater. So distance is one thing you need to highlight because they give you a scale. Estimated distance would be good enough. What are the other things you need to talk about? Okay, so you talk about what happens when you're very near. Okay, destruction by volcanic materials. What happens about the pollution? Okay, you need to go back to figure 3 for evidence of things that are at risk. How do you know these things are at risk? Take a look at where the old volcanic lava flow was. Okay, that gives you an idea of the direction of the previous eruption, the spread of the lava. So similarly, the previous eruption may have spread in a northwestern direction. There's nothing stopping it from spreading directly to the west, same intensity, same distance. Right? If this was towards the west, what areas will be safe? R3, is R3 really totally safe? Right? Is that the reason why in R1 you are not allowed to have any activity at all? R3 you can only have camping and construction, but restricted. Okay, so where do you find actually a lot of the main services and all? Actually beyond R3, right? Beyond R3 in the supposed safer regions. Right, so once again, if you remember, if you look at the map carefully, they give you a scale, they expect you to use the scale to return some of the information back to them. Right, 3B, slab pull force, influence on plate movement. So you need to dig back into your repository of information. What is slab pull force? It's actually the action of the mantle, the cool mantle material that is pulling down, sinking into the mantle area towards the inner mantle layer, waiting to be heated up. When it's sinking down, it's actually pulling your crust that is subducting together with it. So what does this do? This actually enhances only the movement of magma material, okay, and it accelerates the process of convection currents that will lead to plate movement being more dramatic. So it is not on its own very efficient, but it is an enhancement, okay, to the convectional currents that exist within the mantle itself. Okay, LRQ preparedness measures are the most effective in coping with threats from earthquake. Now remember what I said in class, you cannot talk about preparedness measures alone, because preparedness measures alone are not gonna really work. So preparedness measures versus your responses. When you are talking about this being most effective, one good way to look at it would be to list 2 preparedness measures, fight against 1 response, and then in your scale talk about which one will actually save more people, save more lives, okay, or which one will allow you to have lesser damage, so lesser money spent as a response to it. Right, so this one is actually pretty straightforward, right, because you're able to look at the responses that you have put out, the preparedness measures that you have put out, and think along either the lines of how many people can be saved, or how many people will die, or how much money it will cost to get back to the state of normalcy. Okay, question 4 here is a typical tsunami question. We have seen a couple of these variations. When they test tsunami, they like to give you data response like this. So they want to give you figure 4. They want you to explain formation of tsunami and changing height of waves as they approach the shore. So you need to start by telling me at each of these 5 points what is happening. Basically, this is a description question. So at 1, keyword is uplift. You need to tell me there's uplift at when you're at point 1. Okay, when you're at point 2, what happens when there's this uplift to the waves there? Okay, there's sudden upward movement of the waves. Are they high? Are they tall? Right, as you move to 3, what happens to the waves as they grow from 2 to 3? Okay, do the waves get does the wavelength increase? Does it decrease? Does the wave height increase? Does it decrease? So note, I'm using key terms like wavelength, wave height to do the description, because it is important. You're talking about tsunami, you need to use specific wave descriptors. What happens at 4? If you look at the sea level, at 4, the sea floor starts to shallow out. So you will decrease the speed of the lower part of the wave, and this is where your crest starts to build, and 5 is where it breaks. Okay, where it slows down even further and it breaks, and that's where the tsunami does the most damage. So this is a purely descriptive question, right? A pure description question, and your expectation is a description of each of the 5 points that is listed. Description question again, how tsunamis are monitored and how this may reduce the impact. So 2 marks for description of how the monitoring is done, what is used in the monitoring process, and you start with what is used for, and with how it's used okay, with the signal being the final product, okay, signal of the tsunami warning. Impact, does it actually reduce life loss? Does it do anything for property? So two areas to look at in potential consideration for impact on people. Okay, five, I think five is the last one. Five is a very old school type of question for convection currents. This is the basis of your plate movement. So they want you to explain why different type of plate boundary can occur. So what are they expecting? They're expecting you to talk about why at A you have divergent plate boundaries, at C you have convergent plate boundaries. Okay, so 5 marks, you need to tell me what is happening, what is happening with the convection currents at A that forces the plates to move apart. Okay, as it rises up, it cools down along the bottom of the crust and it pushes the crust apart. But when you're pushing at this point, at the other end where there's another fracture, you'll be being pushed together. So you have divergence and convergence. Okay, so hopefully this gives you a rough guide of what we're looking at in terms of questions, what we are looking at in terms of providing answers for the questions. Okay, so go and take a look at these. As I have mentioned this many times, if you are going to attempt any of these as your additional work, right, there's no obligation to finish all of it, but the ones that you really think you want to write out and craft, once it's done, send it to me by email. I will get it marked. I will send it back to you. Okay, right, ladies, hopefully this has been helpful for your learning. Okay, I'll see you for the next topic.